Hello everyone, welcome back to CSE Core Concepts in my series of machine learning algorithms with implementation in RStudio. In this video, I am going to demonstrate the working of linear regression with multiple variables in RStudio. In my earlier video, we have discussed about the linear regression with single variable where there was only one dependent variable and only one independent variable, right? Now we are going to deal with the situations where we have multiple independent variables and they determine the values of the dependent variable, and also we are going to figure out that how many variables are actually contributing to the model goodness. Okay, this is what we are going to see. Now let us see, for example, here if you see this vehicle, I have a database of vehicle where we have the labor cost. We have to compute the labor cost. Actually, there are some 7 attributes, okay, but all of them are not required here. We require the labor cost. What we need to compute is how much will be the cost of the labor, which depends on the mileage and the number of labor hours, okay. So state and MCN, these are not required at all here. So we are not going to consider. So basically we are interested in these 3 attributes where we have to calculate the labor cost depending on, we assume that it depends on labor hours and the mileage. So let us see, let us work with it. Okay, so let us get started with RStudio. First we are going to read the data file. Here we do not need to import any specific different library because the function which we will require here is the default inbuilt function. Okay, so let us have a look at here. Let's say we are going to read the CSV file. Let's see. 1 minute. Yeah, so I have my data frame vehicle data has been created, which is of 7 variables. And how many observations are there? 1624 observations are there, right? So let us see a plot first of all. Plot of the data. The attributes which I want to see is the cost versus the number of labor hours. Okay, so labor cost versus I want the labor hours, and I want it as a scatter plot. Okay, so I assume that primarily it depends on the number of hours. The labor cost will depend on the number of hours. So just have a look at it, scatter plot. Okay, you can see the mileage versus labor hours also, that is okay. So let us see the zoom and see, these are the data points. You can see more inclination is towards this lower side. Okay, similarly you can even plot between the mileage, the relationship between the mileage and the, yeah, let's see, mileage and the labor, sorry, I want the labor cost, right? So I want the labor cost and based on the mileage, right? So let's have a look here. So we can create another scatter plot. So this is how it shows. Okay. So now let us first create a model. Let us first create a model which considering both the criterias, that we assume that both mileage and the number of hours is will determine the total labor cost. Okay, assuming this. So let's create a regression model, vehicle regression, and the function is LM function. So what am I going to do is labor cost is dependent on, that is what we want to say, that the number of labor hours plus I am considering the mileage also. Okay, and the data I have to mention, that is the vehicle data. Okay, let's see the summary of the model also. We will create a summary of the model because the statistical inference is important over here. So let us create the model first and let's see the summary of the model. Now let us see. It's very interesting to decode this statistical analysis. Here all the mean, first quartile, third quartile values are given. Fine. Now here you can see here that there are two parameters on which the labor cost depends, as we have told the model. So the first parameter is number of labor errors. For that, the error estimate, t value and p values are calculated. Okay. So this is the p value for the labor hours. Fine. The second attribute is the mileage. For this also the similar p value is computed. Now we want to know how much accuracy. That means we want to find out which variable or which attribute is significantly contributing to the model performance. Now if I look at the p value, let's say I'm considering first the labor hours, right? So if I am considering the labor hours, I want to find out the significance. So p value is giving is what? 3 star. Okay, what is 3 star? That is some e minus 16 raised to the power minus 16. So what does it mean is that 3 star comes over here, that is the value is 0.0001. So here the p value is 0.0001. So if I want to find out the confidence, that is 1 minus p, that is 1 minus 0.001. Okay, 0.001, which comes out to be around 0.999, sorry, 999, which is approximately equals to 99.9 percentage. So this is the p value. Okay, 99%, this is the confidence interval. I hope you understood. That is the accuracy interval. Now for if you are computing for the mileage, okay, so for mileage, what is the p value you are getting? The p value we are getting is 0.201. Okay, so p value is 0.201. So this means if I am subtracting 1 minus p to find out the confidence level, so it is coming out to be 1 minus 0.201. So which is giving me something around 0.80, okay, which is 80%. Approximately it is 80%. Now which p value is more? 99.9, obviously labor hours. Secondly, this value is less than 95%. So if your confidence interval is less than 95%, that means it is not good. Okay, that means what? This indicates that the number of labor hours is strongly contributing to the model's performance. Mileage is not a very important parameter because its confidence interval is 80%, which is less than 95%. Okay, so if you can create, let us create the final model. You can create the final model using only the labor hours. Now let us create one another model, that is the reduced regression model. We will consider only the significant variable. Okay, so we are saying that the labor cost depends on the labor hours. That's it. We are not going to count the mileage, since we have just seen that it is not contributing too much, right? So we will see a summary of the model, that is reduced registration. Fine. So let us have a look at the model summary. Yeah. So now you can see labor hours. Obviously we have seen this, that it was giving us 99.9% confidence interval. Now if you want to find out what is the how much difference you are getting, okay, between the two models, okay, that if you are including mileage, what is the difference, and if you are excluding mileage, what is the difference? So here we will perform ANOVA, that is analysis of variance between these two models. The first model is the reduced registration, that is without mileage, and the second model is the with mileage, that is the first time which we created. So this is the ANOVA which is giving us the error, the results. Okay, so p value what you are getting here is fine. Just yeah. So you are not adding any significant results, right? So this is what you can do the analysis of the variance table. It is being created. So it is computing the RSS or difference of sum of squares and all. It is computing. The answer you are getting something around 3871. Okay. So something around this type of root square of error you are getting. Fine. Now if I want to do a prediction, the model has been created. Now I want to perform prediction. Prediction in the sense that if I am giving some value, see whatever my data was there in the vehicle data frame, based on that data my model learned. Okay, my model learned, and my model while learning it told me that mileage is not an important parameter, only the number of labor hours is contributing. Now let me give some random labor hours and let my model calculate the cost for it. Okay, so let's see vehicle prediction. We want to perform a prediction here to see our model, how our model is performing. So reduce registration because we will not consider the mileage. Okay, data dot frame, because you have to give the value. So labor hours, yeah, so labor hours, let's say I am giving the value 20. Okay, and I want to find out the confidence interval. So interval is equals to confidence. I want to find out the confidence interval here. So okay, so let's see the output, vehicle prediction. Let us see the output. So this is what we are getting as an answer, right? So your fit, a lower value is this, upper value is this. So your value is going to range between, actual curve will fit at 1469.94. This is the actual cost, but your curve can vary. Lower variation is 1456.168 rupees or dollars, whatever you consider, and 1483.713. Okay, so it is ranging between. This is your answer. Now what we have done here is that we gave our complete data set as a training, and randomly I am giving some answer. Okay, randomly I am giving some values so that I can compute the labor cost for me. Now this same thing you can even do use by splitting the data, what we have already done in the earlier models, that whatever data you have, you can split it into two parts. Let's say vehicle data. Okay, so you can always replace is equals to true, and you can say probability is equals to C. You can always mention, let's say 80% and 20%. Okay, now if you are performing in this way, you can actually see how your model is performing, right? Same thing, same steps what we have done earlier in naive Bayes classifier and other algorithms, KNN and all, you can always do. Okay, so what you can do here is that vehicle data. So which part you are going to say PD? You are going to say the first partition is your training data, understood, and the next partition is your testing data. So test. So you have the test data over here, which is equals to vehicle underscore data partition PD is equals to 2, right? So you can partition the data into two parts like this. Okay, and what you can create here, this reduced registration here. So you can just pass on your, what is the data? You can, instead of this whole vehicle data, you can just pass your train data, right? You can only pass your training data here, and you can perform the testing prediction also you can do, right? So prediction, how will you do over here? Let's say for example, you are saying vehicle prediction, reduce registration, but your data will be equals to, you are predicting based on your train data, right? So data is equals to train data. So based on this also you can perform your predictions. So vehicle prediction, you can see the data, all values have been predicted. Now if you want to see how your model is performing, so if you want to see the vehicle prediction with the test data, so also you can write down test. So you can perform the prediction using the test data over here, right? So you have done the predictions using the test data, and this is how you can get the results, right? So you can even compute here, you can even check here whether the values which you are giving is correct or not, right? So training data 80-20 we split, so we created two data frames. So training data contained 1303 observation and test data contained 321 observation. So either you can check for one particular value also the answer, or you can split your data into training, testing, and you can create this type of predictive analysis also. I hope you have understood the model, right? So you understood how it is working, right? So how can you perform this? So you can take some other data also. In this case, you can take some other data even also, that you can find out the answers, right? So you can even find out the root mean square between the predicted value and the model computed value also. So you can find out root mean square error, RMSE. Okay, so you can even find out the average root mean square error, that also you can find out. Okay, so this is how you can perform the you can perform using the insurance data also. So basically what we are doing here is that we are trying to compute the values based on the multiple models. Okay. So now in linear regression with single variable, we had created one file, okay, where we had only one property based on which the insurance was computed. So like this, if you have a data, that is you want to find out the insurance charges, okay, based on many parameters. You have age here, gender here, BMI, number of children, whether smoker or region, okay. But I don't think the number of children and the region will affect whether the insurance charge. No, sorry, it does affect, the region also affects. So you can even consider all these parameters and can compute the charges. Similarly, what we have done in this case, that we have tried to find out the significant variables, that also you can even try and find out. Okay, so what you can do here is that you can read the insurance data and you can even figure out which components are mostly contributing to the parameters, okay, in this case. So I hope you understood this. You can download such data sets from Kaggle or GitHub, and you can also perform on your own how to perform the multiple regression with multiple variables. I hope this is clear to you. If you have any doubts, you can please write in the comment section, and please don't forget to like, share and subscribe to CSE Core Concepts. Thank you.